Good morning, students. Um, I hope you enjoyed your senior retreat that you just got back from yesterday. I know it's been several days since we had a face-to-face time. Today, I'm posting this recording because I've got a circumstance that won't allow me to make today's session. But tomorrow, you should get some FaceTime with me or another instructor. So I want to give you a couple quick updates, as well as maybe do a practice problem or two with you, just to kind of keep you guys focused on moving through the course and doing good work. So I've got some major updates to make you aware of. Grades for the work that you've completed so far are being updated. Okay, so the assignments from topics 1 and 2 that I've seen from people, I've already entered the grades for. Okay, you can access those grades by clicking this button over here on the left side of your screen. It says grades. I'm not going to click it because I don't want to show you everyone's grades in the course. But if you click that, you're going to see your grades. Now, there was an issue with the grades. For some odd reason, the course settings have been automatically giving you like zeros anytime you submit work. And I don't really know why that's been happening, but I had a couple students emailing me saying, hey, I'm really concerned. I'm doing really bad in the assignments. What am I doing wrong? You're not doing anything wrong. It's just that this website is automatically putting zeros in for some odd reason. So I went through and I fixed those. And I also made the assignments from topics 1 and 2 a completion grade. So if you did the assignment, I gave you 100%. And the reason I did that is because we've had some struggles over the past few weeks getting you guys caught up, getting you guys understanding material. Hopefully that's changing now that we're meeting a little bit more often. But just to kind of make it easier for you guys, I made that a completion score. So if you haven't quite turned in all the assignments from topics 1 and 2, you're kind of missing out on those completion points. So get those to me as quickly as you can. For the quizzes though, so if you go to the quizzes in topics 1 and 2, those, just to be fair to those who are really spending time on them, the quizzes I will grade on accuracy and effort, okay? So everything above the quiz in topic 1, if you did it, you got 100%. The quiz itself, I will grade for accuracy. The same goes for topic 2. Everything in topic 2 in the assignment side of things is going to be graded completion, and the quiz itself is going to be graded on accuracy and effort. Okay. All right. So let's talk about topic 3 real quick. Topic 3, I know, has been a challenge for a lot of you, especially the honors course, since we've been having glitches with our meetings due to Wi-Fi issues and whatnot. So topic 3, I know I wanted to do like this week at the beginning of the week. I'm going to push that due date back until the end of this week, so Sunday at midnight. If you can get topic 3's assignments done by Sunday at midnight, that's a good goal to aim for. Okay. Now, topic 3, I'm kind of changing things a little bit from what you're used to. Now, I've already made the changes in the non-honors class. In the honors class, I'm just finishing the changes up. But let me kind of show you what I'm changing about the assignments. In the past, the assignments were in this lesson format, and you can recognize it by the icon right here. So it's kind of hard to see the difference between these two icons. But before I made these changes, the icons looked like this. Okay, you see this icon right here with the lines across it? It almost looks like a page of notes, let's say. Before, the icons looked like that, and these lessons, they would not allow you to attach your work. So if you did work on pen and paper, many of you, all of you, I think, were having trouble actually scanning your work into me because the lessons would not allow you to attach them. So, and that was making it difficult on me because as the grader, I need to be able to see your work to give you an accurate score. So I've changed the assignments to be this icon. Okay, this icon you can see it's more like a check mark list. So you see those checks on the side. So this checklist icon, that's the assignment that I want you to complete. Okay, you'll notice that these are clones of each other. This is conceptual questions. This is conceptual questions. Down here, I've got more clones: vector addition, subtraction, graphical methods, vector addition, subtraction, graphical methods. So if you haven't yet completed some of these assignments, don't do the assignments with the plain lines across them, do the assignment that is in the check mark icon style, okay? Because those are the assignments that are going to allow you to submit work. Now, once I've updated all the grades for topic 3 that have already been submitted, like let's say, well, Mr. Barris, I've already done the assignments with the little lines across them. That's fine. I will grade those and I'll just deal with it. But if you haven't done an assignment yet, make sure you do it in the check mark icon now, because I want to change the culture, so we're doing that so that we can show our work and make it easier for all of us. I will remove these other lessons once the grades are removed, so it'll be nice and easy for you. But once again, loud and clear to all who can hear the sound of my voice. From now on, do the assignments that have the check marks. Don't do the assignments with the icon with the lines across them. Okay? All right. I think that's kind of all I wanted to talk to you about as far as the changes to the course layout. One thing that also came up with a student, there may have been some of you whose communication has not been reaching me. If you're trying to send me emails through Maestro, that is not the best way to reach me, because up until this point, I haven't really been receiving those messages because Maestro is not forwarding them to my actual email. So I need you guys to send any emails or questions you have to me directly to my email. So here's my email. I'm going to put it up on the screen. It is zane.barris@myvsoe.com. Okay, if you send me messages there, I will get them and I will respond in a timely manner. Hopefully those of you who have been corresponding with me over email can testify to the fact that I'm pretty quick at getting back to you. Sometimes I'll get back to you within like a minute of receiving your email. Okay, but please send me communications here from now on, and that way those messages will get to me. Okay, let's do a couple practice problems with the time we have left. So the videos that have already been posted to the announcements over the past several days should be helping you with the vector addition and subtraction assignments, the projectile motion assignment. So I've done videos to help you with these 3 assignments: graphical methods, analytical methods, projectile motion. So watch those videos that I've posted over the past several days to get the process and the steps for how to do those problems. Okay, I haven't really touched this assignment in my videos yet, and the reason why is because it's kind of a combination of the concepts you learn from these assignments up here. But just because we haven't done it, I'm going to do one for you right now. Okay, so let's click into this assignment. Once again, you're clicking on the check mark icon. You can see the assignments all in one spot now, so you should be able to attach your files to this assignment from now on. And the way you do that, by the way, if you go down to the bottom of the page, it says add submission. That's how you add an assignment. Once you click on that, it's going to give you the option to attach a file. Let me show you that real quick, just because we have the time to do it right now. Okay, so once you click on add submission, at the very bottom, you're going to see a little icon right here. It's a little document. If you click that, it's going to open up your computer's Explorer. You can choose the file. So if you did your work on pen and paper and you scanned it in your computer, you can upload it by choosing that file and hitting upload this file. That's how you get work to me. Okay. All right. So let's do a problem. Okay. Let's do problem 4. Okay. So I'm going to copy this over to a Word document just so we have a nice white space to draw on. Okay, so once again, in any problem you do in topic 3, you have to make a drawing so that you can understand the vector math that's going on. So this problem says this: a jet airplane flying from Darwin, Australia has an airspeed of 260 meters per second in a direction 5 degrees south of west. Okay, so I'm going to draw a picture to represent this so far. So here are my axes. Okay, we know that on your axes, this is your x-axis, this is your y-axis, obviously. But since we're dealing with an airplane problem, let's treat this as a compass rose. So this is east, this is west, this is south, this is north up here. Okay, so this airplane is traveling with an airspeed of 260 meters per second, and it's going in a direction 5 degrees south of west. Okay, so I'm going to go west, and I'm going to go down 5 degrees from west. So it's going to be a very small angle right here. Okay, so this angle right here is 5 degrees. It's kind of small, so let me draw an arrow. This is 5 degrees. Okay, and the size of that vector is 260 meters per second. So the length of this line is 260. Okay, let's keep reading. It is in the jet stream, which is blowing at 35 meters per second in a direction 15 degrees south of east. Okay, so we're going to add some wind to this plane's path. This wind is maybe pushing against the plane or pushing it to go a different direction. So the wind is blowing 35 meters per second in a direction 15 degrees south of east this time. So I'm going to go east, and I'm going to go 15 degrees south of it. So that's probably like here. Okay, so this angle right here is 15 degrees. 15 degrees. Okay. And its magnitude, the size of that line, is 35 meters per second. So once again, all this information that we're drawing with, we got from reading the problem. Okay, so always, always, always draw a picture when you start a problem in topics 2 and 3. Okay, now they're asking me, what is the velocity of the airplane relative to the Earth? So in other words, if the plane's trying to go 5 degrees south of west at 260 meters per second, but the wind is blowing 15 degrees south of east at 35 meters per second, the plane is going to get blown somewhat off its intended path. And we're going to find that actual path the plane is now traveling by adding these two vectors together. Okay, so here's what you want to do. First step, after you draw, so I'm going to write these out. So step 1, draw a picture. Okay. Step 2, okay, and if you've been watching the videos this past week, hopefully step 2 is going to be pretty easy for you, but step 2 is to resolve your components with trig. In other words, SOHCAHTOA. Okay, SOHCAHTOA. So I'm going to take a look at these two vectors I've drawn. I'm going to make them right triangles to make them easier to deal with. So let me do this in orange. So you can see this red vector, I'm making a right triangle right now. So we know that this is our y component since it's our vertical leg of our triangle. This is our x component because it's the horizontal leg of our triangle. Okay, so remember that SOHCAHTOA, you can say we were using sine. So sine stands for opposite over hypotenuse. So the sine of 5 degrees should get us our opposite side of the triangle over our hypotenuse. So if you look at the 5 degrees, which I drew here in red, the opposite side of the triangle to that 5 degrees is your y component. Okay, so that's my opposite side. So I'm going to put my opposite, which I don't know, over my hypotenuse. Now my hypotenuse is right here. It's the longest side of the triangle. So that's 260. 260. Okay, and we got that by knowing SOHCAHTOA. So means sine equals opposite of hypotenuse. Now using math, we need to get y by itself. Okay, so if I times both sides by 260, so times 260 times 260, that's going to get y by itself. So these 260s are going to cancel. And then whatever 260 times the sine of 5 degrees is, that's going to be what y is. So let me type that in my calculator right now. And please follow along if you're watching this. So my calculator, I'm going to type in 260 times the sine of 5 degrees, and I get negative 249.3. Okay. All right. So that's my y component of my vector. Okay. Now, one thing I'm noticing though. Okay, well, let's keep going. So that's going to give me my y component. Let's go ahead and get our x component by doing the same thing. So to get my x component, x is right here. So you'll notice that the x component is adjacent to my 5-degree angle. So I'm going to use cosine because cosine stands for adjacent over hypotenuse. So cosine right here in our acronym, so COTA. So the cosine of 5 degrees is equal to x over my hypotenuse, which is 260. Okay, and once again, you're going to get x by itself by timesing 260 over. So my cosine of 5 degrees, I'm going to times that by 260, and I get 73.75, let's say. 73.75. Okay, so I've got my x component, I've got my y component. We are good to go. Now let's look at the blue vector. Okay, so all of this work right here, this was for the plane. Okay, let me write that down. This is the plane. Let's do the work for the wind now. So let me change colors. I'm going to go pink now. So down here, we're going to do the work for the wind. Okay, so the blue triangle now, let's make it a right triangle by giving it some legs. Okay, so this is our y component over here. This is our x component. Okay, so we're going to do the same thing. To figure out what y is, we're going to use sine. So the sine of 30 degrees is, so the sine of, the sine of 15 degrees, that's our angle, is equal to opposite over hypotenuse. So opposite is y, hypotenuse is 35. Get y by itself by timesing that 35 over. So in your calculator, when you get y by itself, okay, 35 times the sine of 15 degrees, okay, I get 22.76. So that's my y component right there. Okay, let's do the cosine now. So cosine is going to give me my x component. Okay, so cosine of 15 degrees is equal to x over 35. X over 35. Okay, in your calculator, go ahead and get x by itself by multiplying that 35 over to the other side. So the cosine of 15 degrees times the 35 is going to give me negative 26.59. Okay. All right, so that's the work for the wind. So all this is for the wind. Okay, so now what we're going to do, we just did step 2. We resolved the components with trig using SOHCAHTOA. Step 3, plug in all horizontal and vertical components into Pythagorean theorem. Okay, let me move this up so you can see it a little bit better. So step 3 is plug all horizontal and vertical components into Pythagorean theorem. So remember, Pythagorean theorem says a squared plus b squared equals c squared. You learned that in geometry class, right? What we're going to do is we're going to take our two y components, okay, which are this guy and this guy, okay, and let's go ahead and plug those into Pythag. Okay, so this is going to be, let's say, our a in Pythag, so negative 249.3 plus 22.76 squared It's a square up there. Okay, so that's kind of like our a squared. Okay, now let's do our x components. This is going to be like our b squared. So our x components were 73.75 plus negative 26.59. Okay, so that's kind of like our b squared. So we have this giant parentheses, which is a squared. We have this giant parentheses, which is b squared. Let's set that equal to c squared. Okay, so now you can use algebra to figure what c is. Okay, so I'm going to do that real quick. So negative 249.3 plus 22.76. I'm going to square that. And I get 51,320 about. I'm going to add that to, let's do the second parentheses now, 73.75 plus negative 26.59. I'm going to square that. I get 2,224. Okay, and that's equal to c squared. So we're just simplifying as we go. So if I add those two numbers together, I get that c squared is equal to 53,544 is equal to c squared. Let's go ahead and square root to get c by itself. And I get that c is equal to about 231 meters per second. Okay, so let's give you kind of some context of the problem. The plane was trying to go the plane was trying to fly 260 meters per second in this direction, 5 degrees south of west. But the wind is countering its motion by blowing 35 meters per second in direction 15 degrees southeast. So the plane's final speed, after trying to push against that wind, is our answer, 231 meters per second. That's how fast the plane is actually traveling, despite its efforts to travel at 260 meters per second. Okay, that's basically how you answer part A. Part A said, what is the velocity of the plane relative to the Earth? It's 231 meters per second. Part B says, discuss whether your answers are consistent with your expectations of the effect of wind on the plane's path. So would it make sense, would it be reasonable that a plane trying to go southwest while the wind was simultaneously blowing southeast, would it make sense that the plane wouldn't be able to travel as fast if it was trying to travel into that wind that was blowing southeast? Yeah, that's possible. The plane's definitely going to be encountering some resistance due to that wind, so the speed would be lower. That's what we'd expect. Okay, so you can see this is very similar to the videos I posted last week for the other 3 assignments in the topic. So the addition of velocities assignment for this week, it's very similar to what you've been doing. Okay. I'm going to stop the recording now that we've done an example together. If you're having issues, please talk to your neighbors, email me so we can get you on track. But there are now 3 good examples up on the course in these videos that you can reference as you complete the assignments for topics 3. Please get those done as soon as you can so we can start moving on to topic 4, and hopefully those completion grades will kind of help you out in your grades. All right, good luck today, guys. I will see you next time.